In the last lecture we have seen how to convert a partial differential equation into a set of algebraic equations using finite difference approximations. We have done that in theory, we have not done it completely. So, now we will do a tutorial on this so that we can understand the steps very clearly and convert the same equation into a system of equations and check for ourselves that we have a complete system which when solved will give us the required solution. We are going to do a tutorial on fully developed flow through a rectangular duct in which we subdivide the domain into 16 tiles, 4 by 4 grid rather than the 5 by 5 that we had earlier. So, we are looking at a rectangular domain with walls on all the 4 sides, which is divided into 1, 2, 3, 4 cells in along the x direction and 4 cells along the y direction. So, we have I equal to 1, 2, 3, 4, 5 and j equal to 1, 2, 3, 4, 5. And we would like to solve the equation dou square w by dou x square plus dou square w by dou y square equal to constant c, where c is minus 1000, delta x is 0.1 and delta y is 0.05. Here, when we consider the domain here, there are all these points on the boundary where velocity is equal to 0. So, in all the positions where you have crosses, the velocity is known and it is 0. And it is at these interior points marked by circles is where we would like to get the velocity, which will satisfy this equation. So, we need to get velocity at 9 interior points. So, the tutorial problem is what is W at the 9 interior points. Specifically, what is W22, W23, W32, W42 and then W23, W33, W43 and then W24, W34, W44. So, these are the 9 velocities that we need to determine, and all the other velocities are equal to 0. And how do we do this? We have said that we would convert this equation, we would make a template for this using second order accurate finite difference approximations for the second derivative in x and second derivative in y, and our template was that W I plus 1 j minus 2 W I j plus W I minus 1 j divided by delta x square plus W I j plus 1 minus 2 W I j plus W I j minus 1 divided by delta y square equal to c. in a case where C is a function of x and y, this C here would become C I comma j. We know this function, so we substitute xi and yj here and then get the value of C at ij and we put it as C I comma j. But right now it is not a function, it is a constant. For the case of fully developed flow, C is a constant. So it has a value here and we have minus 1000 as the given value. So now we start writing down the equations for each of these, developing equations for each of these. So that means that around each point, each of these points, we apply this template and get the corresponding algebraic equation. So we start with point 22. For this case, we can write this as W32 minus 2W22 plus W12 divided by delta x square plus W23 minus 2W22 plus W21 divided by delta y square equal to minus 1000. And we know that delta x is this and delta y is this, and we also know that this is 0 and this is 0, so that we can write this as 100 W2, we have minus 200 and minus 800, that gives us minus 1000 W22, and then we have plus 400 W23 equal to minus 1000. So this is the equation we have for 22. Let us go on and write down the same thing for 32, 42 and all these things. I would like you to do it on your own, but we will also do it here. Point 32, so that is this point here. So we will have 100 of this, 100 W22, and we will have minus 400, minus 200 coming from this and minus 800 coming from this. So we have then we will have this point here, that is W42, and that comes with 100. And then we have this point which is 33, and that comes with a coefficient of 400. Okay, so we are essentially following this lead here. For this point, variation in the x direction, that is why we have this W32, and that gives us a multiplying factor of 100, because this delta x is 0.1 and 0.1 square is 0.01. So 1 by 0.1 will give you 100 here, and a variation in the y direction, so that is W23, for example here, is divided by delta y square, and delta y is 0.05, so that gives us a multiplicative factor of 400. So we get minus 2 divided by 0.05 whole square plus minus 2 divided by 0.1 whole square, so that gives us 1000, 200 here and 800 there. So that's how we have written for this. Now we go to 42. 42 is this. So we get this one with 100, this one is 0, and this one with 400, and this will have 1000. So we will have 100 of 32 minus 1000 of 42 plus 400 of 43 equal to this. So, we have done this, this is over. So, let me tick them here. We come to W23, so that is this point here. So, we get nothing from here and we get 100 of this, 400 of this, 400 of this, and then we have so 100 of W33. So, this is minus 1000 of W23 plus 400 of 24 plus 400 of 22. Equal to minus 1000, and so W33 is this point here. So, we have 100 of this, 100 of this, 400 of this, 400 of this, 1000 minus 1000 here. So, we have hundred of 23 plus 100 of 43 minus 1000 of 33 plus 400 of 32 So, plus 400 of W34 will give us minus 1000. We can also write for 43. 43 is this point here. So, we have 100 of 33, 400 of 44, 400 of 42 and 1000 of this. So, that is 100 of W33 minus 1000 of W43 plus 400 of W44 plus 400 of W42 equal to minus 1000. We now have W24 here. We have nothing here, 100 of this plus 400 of this minus 1000 of this, and this is 0. So, you have 100 of W34. So, this is 24 100 of 34 minus 1000 of 24 plus 400 of W23, that is this point here, equal to minus 1000. And we come to W34, so that is this point here. This point will have 100 of 24, 100 of 44, 400 of 33. okay, and the last point is W44 here. So that will have 100 of this 34 and 100 of this 43. So we have finished for all these things. Okay. So here we don't need anything because there the values are already given and we don't need to write down anything there. So that means that we now have 9 equations. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 equations. And these 9 equations need to be solved together. Okay. So let us see what kind of equations these are. Firstly, we can see that these are all algebraic equations because all the w's are just some real values which will be the velocities, and the coefficients are numerical coefficients, constant coefficients here. And we would like to put this in the form of a matrix and we see what kind of matrix we get. So what we try to do is we try to make a lexicographic ordering. Okay. So essentially if you have some Fijk, okay, you can, and there are I takes values from 1 to 10 and j takes from 1 to 10 and k takes from 1 to 10 like that. So you can order them in a sequential way in which, for example, I has a value, j has a value, and then k keeps changing from 1 to 10, and then once you get up to k equal to 10 and then j changes, and then with a fixed value of j then k changes like that. So that is one possibility, or you can also do it in the other way. I changes first, j and k is fixed, and then once I is exhausted only then j changes, and then again I keeps changing like that. So let us try to see what we have. We have 2 indices here, and let us put them, let us define a variable matrix W. So we would like to put all these equations in the form of AW equal to B, where W contains all the velocities which are unknown, and we would like to order them in a certain way in the lexicographic way. So we can say that W consists of W22, W32, W42, and then W23, W33, W43, and then we have W24, W34, W44. This is all the transpose, because here W is a column matrix and there are 9 elements in this representing the 9 unknowns. Okay, so there are 9 elements. So this is a vertical a column matrix here, and this A is a 9 by 9 coefficient matrix, and B is the corresponding right hand side value for each of these equations. So let us try to fit this in this and try to find out what the coefficients of A can be. So for this we will just copy down these things here. So, we have W 22, 32, three, okay. So, this is just a mnemonic for us to just understand. Our coefficient matrix is this, and when we look at the first equation, we see that it has 100 of W32 and for W22 we have minus 1000. So, we put minus 1000, and W23 it has 400, W23 it has 400 here, and all the others are 0. Okay. Now, you come to this equation here, and W32 is minus 1000, W22 is 100, W42 is 100, W33 is 400, and all the others are 0. Okay. Now, we take this one here, W42 is minus 1000, W32 is 100, W43 is 400, and all the others are 0. So, 0 here, 0 here, 0, 0, 0, 0, and we come to this one here, W23 is minus 1000, 33 is 100, 24 is 400, and 22 is 400. The others are 0, 0, 0, 0, 0, 0. Okay, so now we come to this one here. So, W33 is minus 1000. So, we can put the major value here, minus 1000, and then we have 23 is 100, and 43 is 100, Three two is 400, and 34 is 400, and others are 0. Okay, so we have done 4-3 is done. No, so we come to the 4-3 equation. So here 4-3 is minus 1000, 3-3 is 100, 4-4 is 400, 4-2 is 400, others are 0. Now, 2-4 is minus 1000, 3-4 is 100, 2 3 is 400 and all the others are 0. Okay. And here we have 3 4 as minus 1000. We have 2 4 as 100. Four 4 as 100. Three 3 as 400. We have 0. And then we come to the last equation, which is 4 4 is minus 1000. 3 4 is 100. And 4 3 is 400. So this is our coefficient matrix. We have the variable matrix W, which is a column vector, and then B happens to be the same minus 1000, minus 1000, one, 2, 3, 4, 5, 6, 7, 8. Okay, and similarly we can write W. In the way that we ordered, we have to maintain the same order here. So W22, W32, W42, W323, W33, W43, and then W24, W34, W44. So we have converted this partial differential equation into AW equal to B. So this is the end of this tutorial. In the next lecture, we will see how we can solve this.